Hello everyone, welcome. This is 7th chapter, Distributed Objects. The remote method invocation, RMI. RMI has its origin in a paradigm called a remote procedure call. So remote method invocation or RMI is the distributed form of remote procedure call. Okay. So the procedural language, procedural programming predates object oriented programming. So in procedural programming, a procedure or a function is a control structure that provides the abstraction for an action. Okay, so procedural programming, we have procedures or functions, and the action of function is invoked by a function call to allow for variability. A function call may be accompanied by a list of data known as arguments. The value or the reference of each argument is said to be passed to the function, and it may determine the action actualized by the function. The conventional procedure call is a call to a procedure residing in the same system as the caller, and thus the procedure call can be termed a local procedure call. So in remote procedure call, so in procedure call we have procedures, and a function call or a procedure call is made with the list of data or list of arguments, and some action is taken place in the calling function, and a return value is provided to the caller. Okay, so the procedure call is a call to a procedure residing in the same system as the caller, and this procedure call is called as a local procedure call. So these procedures are in the same system. So in the remote procedure call model, a procedure call is made by one process to another, possibly residing in a remote system with the data passed as arguments. So when a process receives a call, the actions encoded in the procedure are executed. The caller is notified of a completion of the call, and a return value, if any, is transmitted from the callee to the caller. See, a remote procedure call is also same as a local procedure call, except the procedure is executed in the remote system. So caller and callee are on different systems. See here, the remote procedure call, the process A in a separate system, and process B also in a separate system. So process A makes a call to process B with the arguments argument 1 and argument 2. So process B here, it makes a call to process B of a remote system, and here the action is triggered. Okay, the predetermined task is performed here, and a return value is provided to the process A, the caller program. Okay, and so it will continue with the program flow. So this is how a remote procedure call paradigm works. So based on the RPC model, a number of application programming interfaces have emerged to mask the details of inter-process communications. Each remote procedure call is transformed by a tool called RPCgen to translate a local procedure call directed to a software module common termed as a stub, or more formally a proxy. So via the proxy, message representing the procedure call and its arguments are passed to the remote machine. So here in inter-process communications, each remote procedure call is transformed by a tool called RPCgen. So there is a tool or a software module RPCgen to translate a local procedure call to translate a local procedure call directed to a software module common termed as a stub, or formally a proxy. So the RPC gen will translate a local procedure call. Okay. The remote procedure call is transformed by a tool called RPC gen. So here, when a remote procedure call is made, but a remote method is invoked, okay, a action is taken place in the remote system, but the remote procedure call should be translated or transformed by a transformed to local procedure call at the remote system. Okay, the procedure call is a remote procedure call. When it reaches the remote system, there the remote procedure call should be transformed as a local procedure call, and this task is done by a tool called RPC gen. Okay, and so at the other end, the proxy receives the message and transforms it to local procedure call to the remote procedure. And there is a figure. It shows the behind the scenes of transformation of a remote procedure call into local procedure calls and intervening message passing. So the proxy is employed on either side to provide the runtime support needed for the inter-process communications, carrying out the necessary marshalling and socket calls. So the marshalling is the encrypting. Okay. See, this is the figure. So here, first one is the local procedure call. Host A, the procedure 1 makes a call to local procedure call to a procedure 2 residing on the same system. Procedure 1 makes a call to procedure 2. Okay, so here it makes the call to procedure 2, and here in the procedure 2 the action is performed and the return value is sent to procedure 1. So this is the local procedure call. See here, this is the remote procedure call. So what happens here in remote procedure call? So there are two machines, host A and host B. Okay, see the first step, procedure 1 on host A makes a call to procedure 2 on host B. So procedure 1 on host A makes a call to procedure 2 on host B. So now the runtime support maps the call to the proxy on host A. So there is a proxy on host A and also proxy on host B. Okay, the procedure 1, the runtime support maps the call to the procedure on the host A. So the proxy on host A. So the proxy marshals the data and makes an IPC call to proxy on host B. So the proxy residing on the host A, it marshals the data and it makes the call to proxy on host B. So here, next, the proxy on host B unmarshals the data received and issues the call to procedure 2. So here the procedure on host B, there is a proxy, and this proxy receives data, marshaled data from host A, and the proxy unmarshals the data and it issues a call to procedure 2. Okay, so the code in procedure 2 is executed. So code in procedure 2 is executed and returns to the proxy on host B. So the executed and the return value is sent to the value is returned to proxy on host B. So the proxy on host B marshals the return value and makes an IPC call to the proxy on host A. So here the proxy on host B marshals the return value and it makes a call to proxy on host A. Okay, so the proxy on host A receives the return value and unmarshals the data and forwards the return value to procedure 1, so which resumes its execution flow. Okay, so this is how a remote procedure call is made. So now the Java RMI architecture. The Java RMI architecture calls for proxy software modules to provide the runtime support needed to transform the remote method invocations to local method call and to handle the details for the underlying inter-process communications. In this architecture, three abstraction layers are present on both the client side and the server side. Okay, so in Java RMI architecture, there is a proxy software module. Okay, on both sides, at the client side and at the server side. And this proxy software module, it provides the runtime support to transform the remote method invocations to local method call. See here the Java RMI in Java RMI architecture, so it is remote method invocation. So we need to convert that remote method invocation, remote methods into the local method call in at the server side. Okay, so this is done by the proxy software module. So first of all, the client side architecture. So here we have three abstraction layers are present on both the client side and server side. So three layers are the stub layer, the remote reference layer, the transport layer. Okay, so let us see the diagram of the RMI architecture. So this is the RMI architecture. There is a directory service and object client, object server. There are three layers at one at client side, that is stub, remote reference layer, transport layer. So at server side, skeleton layer, remote reference layer and transport layer. Okay, so our object client makes an method call to object server. So first of all, it will look into the directory service. Okay, it will look into the directory service for the reference for the object. Okay, remote object. So the object client will get the reference for the object, remote object, and it will invoke the remote object at object server. But actually physically tasks are taken place. Okay, so it will cross all these three layers. The method call will trigger the actions here in stub, remote reference layer and transport layer. So first of all, we will see at client side architecture. So the stub layer, the client processes remote method invocation as directed to proxy object known as a stub. The stub layer lies under the application layer and serves to intercept remote method invocations made by the client program. Then it forwards them to the next layer below, the remote reference layer. So this first one is stub layer. The client processes remote method invocation is directed to proxy object, that is known as stub. So the client process remote method is directed to the stub. The stub layer lies under the object application layer and serves to intercept remote method invocations made by the client program. Then it forwards them to the next layer, that is remote reference layer. Okay, the client processes remote method invocation is directed to stub, and stub will transfer it to the next layer, that is remote reference layer. So the next one, second one, is the remote reference layer. The remote reference layer interprets them and manages the references made from clients to the remote service objects and issues the IPC operations to the next layer, the transport layer, to transmit the method calls to the remote host. So here the remote reference layer interprets and manages references made from clients to the remote service objects and issues an IPC operation. So the remote reference layer is responsible for interpreting and managing the references made from clients and issuing the IPC operations to the next layer, that is the transport layer. So it will transfer the call to the next layer, that is transport layer. So the third one is transport layer. So here transport layer is a TCP based, therefore it is connection oriented. So this layer and the rest, the network architecture, carry out the IPC, transmitting the data representing the method call to remote host. So ultimately the transport layer, TCP based transport layer, which is connection oriented, will transfer the call to the remote host. So at server side there are three layers. So first one is skeleton layer and remote reference layer and transport layer. The skeleton layer lies under just below the application layer and serves to interact with the stub layer on the client side. So we have stub layer on the client side. So the skeleton layer on server side will interact with the stub layer on the client side. The next one is the remote reference layer. This layer manages and transforms the remote reference originating from the client to local references that are understandable to the skeleton layer. So here this remote reference layer is at the server side, and a method call is made by a client. So the remote method call should be understandable by the skeleton layer, so that it will transform the remote method to local call, okay, local references. So remote references to, it will transform, the remote reference layer is responsible for transforming remote references to local references which are understandable to the skeleton layer at the server side. So third one is this transport layer. This layer is connection oriented, that means TCP based in the TCP IP network architecture, okay. So there is a object registry. The RMI API makes it possible for a number of directory service to be used for registering a distributed object. So here the servers will register their objects in the object registry. So here it is RMI registry, or it is called directory service. One such directory service is Java Naming and Directory Interface, JNDI. The Java RMI registry, a simple directory service, is provided with the Java Software Development Kit SDK. The RMI registry is a service whose server, when active, runs on object server's host machine. So here object registry will run on the server host, okay. So this is the Java RMI architecture. Object server, this is the server machine, and this is client host, server host and client host. So this directory service, there is a directory service where all the server host or server host will register its objects in the directory service, okay. So here this directory service will run on the object server's host, that means on server. So object client makes a method call. First of all, it will access the remote reference from the registry or RMI registry or directory service. So here it will access a remote reference from directory service, and using that reference it will make a method call to object server, okay. And all these underlying processes are taken place. These are all the underlying processes. Here object client, it will transfer the call to the remote method call to stub, and stub will transfer it to remote reference layer, and remote reference layer will make some inter-process communications, and there is a transport layer which is the TCP based, that is connection oriented. So it will transfer the call to the transport layer of object server, and remote reference layer is responsible for transforming the remote method call to the local method call, which is understandable by the skeleton. So this skeleton will interact with the stub, that means it will send the return value to the stub, but the skeleton will marshal the return value and it will transfer it to remote reference layer, and it is transferred, and the skeleton is it will interact with the stub. So this is the Java RMI architecture. So now algorithm for developing the server side software of the Java RMI architecture. So we have skeleton, remote reference layer, we have transport layer. So for this architecture, we have the algorithm, how to develop the server side algorithm software. So first of all, open a directory for all the files to be generated for this application. And second step is specify the remote server interface in some interface.java. Compile and revise it until there is no more syntax error. So third step is implement the interface in some implement.java. Compile it and revise it until there is no more syntax error. Fourth one, use the RMI compiler, RMIC, that is RMIC, that is RMI compiler, to process the implementation class and generate the stub file and skeleton file for the remote object RMI sum implement. The files generated can be found in the directory as sum implement skeleton class and sum implement stub class. Step 3 and 4 should be repeated each time a change is made to the interface implementation. Fifth step is create the object server program sum server.java, compile and revise it until there is no more syntax error. Sixth step is activate the object server Java sum server. So the developing server side software, first of all, open directory for all the files to be generated. The second one is specifying the remote interface. Second one is specifying remote interface. Third one is implementing the interface. Fourth one is using the RMI compiler. And fifth one is creating the server. Sixth one is activating the object server. Okay. So opening directory for all the files and specifying the remote server, specifying the remote server's interface, second one is specifying remote server's interface. Third one is implementing the interface. Fourth one is using Java RMI compiler and the creating stub and skeleton file. And fifth one is creating server file. Sixth one is activating the object server. So here this is algorithm for developing the client side architecture or client side software. First one is open a directory for all the files to be generated for this application. Second one is obtain a copy of the remote interface class file. Alternatively, obtain a copy of the source file for the remote interface and compile it using Java C to generate the interface class file. Third is obtain a copy of stub file for the implementation of interface. So fourth one is develop a client program, some client.java, and compile it to generate the client class. Fifth one is activate the client. Okay, so algorithm for developing client side architecture or client side software is first one is opening directory for all the files to be generated. Second one is obtaining a copy of remote interface class file already created at the server side, and second step is obtaining a copy of remote interface class file and generating the interface class file using and compiling using Java C. Third one is obtaining the copy of stub file and for the implementation of interface. Fourth one is developing client. Fifth one is activating the client. So now the testing and debugging. Testing and debugging RMI application. The first step, build a template for minimal RMI program. Start with the remote interface containing a single method signature, its implementation using a stub, a server program that exports the object, and a client program with just enough code that invokes the remote method. Test the template programs on one host until the remote method can be made successfully. The second step is add one signature at a time to the interface. With each addition, modify the client program to invoke the added method. Third is fill in the definition of each remote method one at a time. Test and thoroughly debug each newly added method before proceeding with the next one. Fourth is, after all remote methods have been thoroughly tested, develop the client application using an incremental approach. With each increment, test and debug the programs. Fifth one is, distribute the programs on separate machines, test and debug. So this is how to test and debug an RMI application. The first one is, build a template for minimal RMI program. That is, do not build a whole RMI at once. First start with a minimal RMI program with the remote interface containing a single method, and its implementation using a stub and server program and a client program. Okay, while at initial stage just have one single method and a stub file and a server program that exports the object and with the client, and test the template programs on one host until the remote method can be made successfully. So you should make the remote method using this one method, using one client program and one method. So if this test the template programs on one host until the remote method can be made successfully. Okay, so the first step is building the template with the minimum RMI program. Okay, do not build the whole program at once at initial stage. The second is, add one signature at a time to the interface, and with each addition modify the client program to invoke the added method. Okay, so when you add the methods, so you should add one signature or one method at a time. Okay, and for that you should modify the client to invoke the added method. And third one is, fill the definition of each remote method one at a time. So for all methods you will have to fill the definition. Okay, first one is declaring the method, and next you will have to fill the definition for all the methods. Test and thoroughly debug each newly added method before proceeding with the next method. So fourth one is, after all remote methods have been thoroughly tested, develop the client application using the incremental approach, one by one. Okay, the incremental approach is one by one. With each increment, test and debug the programs, and distribute the programs on separate machines, test and debug. Okay, after the compiling, after the successful compilation of the whole RMI program, distribute the programs on separate machines. So now the comparison of RMI and socket APIs. The remote method invocation API as representative of a distributed object paradigm is an efficient tool for building network applications. However, you should be aware that the gain in convenience is not without its drawbacks. So some of the trade-offs between RMI API and socket API are enumerated below. The first trade-off is, the socket API works closely with the operating system and hence has less execution overhead. RMI requires additional software support including the proxies and directory service, which inevitably incur runtime overhead. So for applications that require high performance, the socket API may remain the only viable solution. So RMI requires additional software like proxies and directory services, which inevitably incur runtime overhead. So it will incur some runtime overhead because we know RMI requires additional software supports like proxies and directory services. So there is a overhead, runtime overhead will be there, but in socket APIs there is a less execution overhead because it works closely with the operating system. But here in RMI we have there is a overhead. For applications that require high performance, the socket API may remain suitable. Okay, the suitable is socket API for applications that require high performance. So on the other hand, the RMI API provides the abstraction that eases the task of software development. Programs developed with a higher level of abstractions are more comprehensible and hence easier to debug. So here our Java RMI provides the abstraction, high level of abstraction, so it is easier to develop, and so it is easier to develop and debug. So third one is because it operates at a lower layer, the socket API is typically platform and language independent. Okay, socket API is language or platform independent. The same may not be true with the RMI. The Java RMI, for example, requires Java specific runtime support. As a result, an application implemented using Java RMI must be written in Java and can only run on Java platforms. Okay, so this is the trade-off between socket API and RMI. See, RMI is socket API has less overhead because it works closely with the operating system, but RMI has additional overhead because we need some additional softwares like proxies and directory services. So but here on the other hand, RMI provides apps high level abstraction, so there it is easier to develop the software and debug the software using RMI, the RMI applications. Okay, so but here the socket APIs are platform independent, so they can run on any machine, but Java RMI is Java oriented, and it requires Java specific runtime support. As a result, the Java applications implemented using Java RMI must be written in Java and can only run on Java platforms.